All right, so now we are on record and we are starting today's agenda with the idea of quadratic equations. There is a lot of theoretical mumbo jumbo that one can do in these type of algebraic topics, but to be really honest, I am the kind of a person who genuinely have this idea that we can solve majority of the questions if we have a clear understanding of what this equations are, if we can predict to some extent the graphs of these equations and so on and so forth, right? So the very first thing that I would want to discuss in the topic of quadratic equation would be the general form, and I'm pretty sure you already know what the general form of a quadratic equation is. This is of the form, so if I consider this to be just, let's say, a polynomial quadratic uh, function, or you can also say a quadratic polynomial, I can write it like this: ax squared plus bx plus c. Now what are these a, b's and c's? These are the coefficient of the terms x squared, x's and c, right? So this is the general form of a quadratic equation, and obviously it would become much more easier for me to explain with a, let's say, if I have a, let's say, some amount of values with me. But before that, let me just quickly see if I have the questions there, or if I have to like generate the questions. Just give me like 1 second, yeah. Okay, chalo, I don't see the questions there. I'll probably take it from the modules anyways. Let's not waste our time. So quadratic equation, the general form ax squared plus bx plus c. And typically, if I have an equation or something of that sort, I will take an I'll take an example and then explain. But typically, if you say, if you realize that for this expression ax squared plus bx plus c, the moment I equate this to 0, it becomes a quadratic equation. Okay, so I'm just going to write it like that. So ax squared plus bx plus c, that is equals to 0. The moment I equate it to 0, becomes a quadratic equation. Now
If it's not equal to 0, then it's not.
then it is just a polynomial, it's a function. It is, we can predict some properties for it, but then the moment we equate it to 0, then we can find the roots, or let's say the positions of the coordinates in an coordinate system. So in an xy plane, we can pinpoint the graph wherever it is. But if it is not equated to 0, then at that point what we can do is probably we can predict whether it is an upward parabola or a downward parabola, situations like this. Okay, so that is precisely why we equate it to a this thing. So one of the important things for us to realize at this point is that suppose I have an equation that is with me. Or just for the sake of simplicity, I'm just going to write it like this only. We already know that the roots can be factorized like this: x into alpha and x into beta. Okay, this is how I can factorize this thing. Okay, now obviously, generally speaking, this is true for all the cases. 99% of the cases, the type of questions that we will be getting, this is exactly of this form. If I'm allowed to, let's say, expand this will be expanded in this way. I'm just going to multiply the x's individually, and then the alpha and all that thing. So I'm writing it over there. Okay, so this is going to be x squared plus or rather, let me write it this, minus beta x, then this is minus alpha x minus of minus is so positive, alpha beta, that is equals to 0. Now if I can interchange the terms, doesn't matter. X square, if I take negative common, you will see my bracket में alpha plus beta of x plus alpha beta. Okay. Now there are two things that I want you to pay attention to. The first thing is that there is no a term in this one. Typically you will see in any of the in the general form of the quadratic equation, you will always see the quadratic equation is written ax squared plus bx plus c. But whenever I'm writing the factor, I'm not introducing that a over there. Now why is that discrimination? That is not a discrimination. Like in as I told you, like 99% of the or 90% of the cases, generally the value of a is 1. Generally the value of a is 1, but ideally we should always remember that there is a attached to x minus alpha and x minus beta. Now what is x minus alpha, x minus beta? These are the factors of the quadratic equation, and alpha and beta are the roots of that quadratic equation. Okay, roots, I'll explain these things with the help of a graph also, don't worry. Ahead I'll explain. But then now I want you to pay attention to this equation. Okay, we are simultaneously taking these two things just so that it becomes easier for us to let's say comprehend this. So what I'm trying to tell you is that if I divide this expression throughout by a, so I'm dividing throughout by a, so I'm getting x squared by a plus b upon a times of x plus c upon a, that is equals to 0. Okay, so I have done this thing, and this is the same thing, mind you. This is the same thing. I'm sorry, this is not going to be x squared by a. This is going to be x squared only, because dividing by a, x squared only. X squared plus b upon a times x plus c upon a times x. Okay. Now let's observe couple of things. We are going to be observing these two equations simultaneously. Okay, because effectively they are same this thing. Okay. What I want you to observe, and I'm changing the color just to make it a little visual, otherwise it's not required. So what I'm saying is that when you see, just now we mentioned that, or I mentioned that these are the roots, and now we are trying to make sense of the roots. Obviously this is the sum of the roots. Okay, if we just visually see this thing, then we will not have to mug up anything. And this is obviously the product of the roots. And now we will compare the product of the root, sum of the root and the product of the root from both the expression, because effectively both the expression are the same expressions. Okay. Typically, as I told you, that typically there should be a outside of this thing. But I am saying that just for the sake of simplicity, in the RHS part, I have eliminated the a just for the sake of simplicity. Okay. Otherwise, it becomes a little challenging for us to visualize it. So let's first of all, let's understand. I'm just shifting it over there. I hope that is not a issue. So if you would just pay attention, sum of the roots alpha plus beta, okay, with the, let's say with the sign is negative. So sum of the roots minus alpha plus beta in the bracket, that is equals to b by a. Can you, obviously you can observe that thing as b by a. And obviously I can shift the negative sign to the RHS. This becomes a minus b by a. And similarly, product of root alpha beta is going to be equal to c by a. Okay. This is where basically we get the idea of sum of roots, product of root. And we are not mugging up any formulas. We are basically visualizing the same thing. So this is your sum of roots. We have already done it for a cubic polynomial in the last class, but right now we are doing it for a quadratic thing, so 1 degree less. So this is sum of roots, and this one is product of roots. What is the beauty of this thing? If I keep on having more and more degrees, so this negative positive thing will occur at alternate steps. So product of roots. Now obviously this is the crux of the discussion that we are supposed to do, and the questions that we have for this session are going to be heavily based out of this idea. Matlab, mota mota, this is what we are going to be looking at. But there is one, let's do, or let me do the discriminant and then come to this one. अच्छा ठीक है, चलो एक एक चीज देख लेते हैं एंड देन वी विल गो टू द आइडिया ऑफ डिस्क्रिमिनेंट्स. ओके, वी विल गो इनटू द आइडिया ऑफ डिस्क्रिमिनेंट. लाइक एक छोटा सा अगर मतलब इरिटेट कर रहा होगा कहीं ना कहीं दिमाग में कि लाइक व्हाट इज द सिग्निफिकेंस ऑफ ए, व्हाई इज लाइक सडनली ही introduce the a and then he's not using that a, like what is this, what is this thing happening? So let's try and understand this part. So I'm zooming out a little bit, and obviously because this is a OneNote, I have the benefit of doing all these things. So let's understand one thing. So now I am taking a function, a proper function f of x, as let's say some random function x squared minus 3x plus 2. Okay. Now obviously this is a quadratic function and it will have its own unique root. If I equate it to 0, okay, if I equate it to 0, you will be able to find the roots of it very easily. The roots of it is going to be nothing but, I know we haven't done the middle term splitting business, but I am pretty sure you have understood what I'm going to do. This one is going to be x minus 1 into x minus 2. So the roots are going to be 1 and 2. Okay, so these are the roots. Now suppose what I do, instead of let's say writing fx or anything, I'm just writing it as the first quadratic, or just let's represent it as a. All I am saying is that if I multiply 2 to this quadratic throughout, so what I'm asking you to realize is that for the same x squared minus 3x plus 2, I'm doing nothing. I'm just multiplying 2 throughout. Okay.
Wait, how did you get 1 comma 2? Like, how did you get these roots?
So this is x minus 1 into x
Oh,
minus
okay.
2. This is basically the splitting of the middle term.
Okay.
So we're splitting it. Now, what I'm saying per se over there is that if I just multiply a 2 to the quadratic equation, so obviously this becomes a 2x squared minus 6x plus 4, that is equals to 0. And if you have understood it, we will obviously multiply this 2 into this thing. This will become a 8, and then we will split the 6 in such a way that we get the product and the sum of the root and the product, sum of the root as minus 6 and product of the root as 8. So effectively what I'm trying to say is that let's check if the roots remain the same or the roots change. So effectively this time around what I will be doing is I will try to split 2 fours are 8. So 2 into 2 into 2 into 2. Okay. I need a 8 product as 8 and sum as 6. How do I do that? How do I split the middle term such that I get the product as 8 but the middle term as 6? Let's do that.
Are you asking me?
Yeah, like I'm also thinking, like I just want to see if whatever I'm thinking is not on like whatever I'm thinking is on the right lines, right? So basically I've just introduced a multiple 2 and I want to see like what changes does it make to the quadratic equation. So right now the quadratic equation, what is this? So right now the quadratic equation is this one with the roots 1 and 2, but I have introduced a 2. How does this change the roots of the quadratic equation? Um,
-2 plus, no, -2 -4 हो जाएंगे ना roots.
-2 -4.
2x square minus 2x minus 4x plus 4. नहीं, हाँ हाँ, actually यही बन रहा है. 2x square minus 2x minus 4x plus 4.
Yeah, 2x square minus 4x minus whatever, like ये तो किसी भी ऑर्डर पे अपन लिख सकते हैं. But this will not, this will give me an 8 also. Yeah. So if I take 2 common, I will get a x square minus 2. And if I take minus 2, hold on, I should take a 2x common. I should take a 2x common. If I take a 2x common, I'll get a x minus 2. And if I take 2 common, I'll get a
Hmm.
x minus 2. This is equals to 0. So x minus 2 and 2x minus 2 equals to 0. Now, if you see, Soumya, this is x equals to 2, one of the roots, and the other root will be x equals to 1. Oh, so there is a peculiarity. There is a peculiarity. I didn't wanted to like upfront say कि roots 1 2 ही होगा अगर हमने कोई भी constant multiply कर दिया इस quadratic equation में. Obviously the root came out as 1 and 2 itself, because 2x equal to 2, it's 1 and 2 only. So am I trying to say that with the introduction of, can you see over there, with the introduction of this a, it doesn't change the quadratic equation whatsoever?
Hmm.
That is what I'm trying to realize, that if I just introduce any random let's say constant, is that not going to change? And I'm just trying to think about it, like logically I'm trying to think about it. This is the significance of that a that we put over there. Because what I was just now mentioning, that whenever we have an expression like this one, x square minus 3x plus 2, generally though it is assumed that a is 1 or whatever. But if I just multiply a 2 into this also, what I'm trying to tell you is that if I take the 2 outside and just make it or reduce the quadratic equation, eventually the introduction of, or let's say, let me put my words correctly, multiplication of a constant to the quadratic equation does not hinder the roots. But Soumya, you have to understand one thing. 2x square, this equation, 2x square minus 6x plus 4 and x square minus 3x plus 2 is, these are not exactly the same parabolas. These are two different parabolas. If I hope this much makes sense. Okay, these are not going to be exactly same. Maybe the shape will be the same. They are obviously going to be u-shaped parabola, upward u-shaped parabola, but they're not exactly going to be the same. Basically, what I'm trying to tell you, one you cannot superimpose onto the other. So either if I am multiplying a, let's say, constant, yes, the roots are remaining the same, but then these two quadratic equations are not same. That is what I was trying to come at. However, this is hardly tested in a aptitude exam setup. You will never be needing it, but you should. Now let me come to the point. Why did I even mention all of this? Because anytime you have an expression like this, general form will always be of the form ax squared plus bx plus c. General form inevitably will be of this form. But every time we write it in terms of, let's say, the roots or the factors, we always write it like x minus alpha and x minus beta. Those are the factors. And through those factors, we conclude the roots of the expression. But we should not forget that there may be a coefficient that is hanging outside. And what is the significance of that coefficient? Because we have divided that coefficient throughout in the process of getting the sum of the roots and the product of the roots. So this is something that you should keep in mind. Uh, a little textbookish, you can say, but yeah, this is something that one needs to keep in mind. However, introduction of the constant term does not change the roots. I hope this much is okay.
Yeah.
All right. So before we go to the graphing of a quadratic equation, which is obviously going to be very interesting, um, let's do one thing which is important, really important for a quadratic equation. If you remember, in the case of a line, obviously this is a curve, a parabola. We don't need the names parabola, hyperbola, ellipse, and all that thing. These are just jargons for us. But to know the names is obviously not going to hurt us, right? So yeah, before we go to the graphing, let's understand something very important, which is the discriminant of a quadratic equation. Now, what is a discriminant? Now, a discriminant of the ax, so for the quadratic function ax squared plus bx plus c is equals to 0. Now this is a quadratic equation, some quadratic equation in a and b. So typically the discriminant is this thing. We indicate the discriminant either by a delta or a d sign, whichever you want to pick, you can pick it. Okay, so the discriminant is b square minus 4ac. This term of the quadratic equation is called the discriminant. Okay, now the nature of the discriminant, I'll explain what I mean by a nature in a while, but the nature of the discriminant will determine whether we get real roots or, let's say, imaginary roots. Typically, if you realize, the discriminant has to always be greater than or equal to 0 for us to get a real roots. Now, I will tell you why I am asking you to remember this thing, because this is where you will, if you, let's say for some reason you forget about the idea of discriminant, then this is something where you can draw the ideas. मतलब एग्जाम में भी फटाक से ये 2 सेकंड में आ जाएगा दिमाग में कि discriminant always has to be greater than or equals to 0 in order for us to have real roots. Now, obviously, this is a quadratic equation, so it will have, let's say, two roots. And why so? Because if you see, the degree of the polynomial is 2, and degree is the basic degree, basically is the highest power of the polynomial. The highest power of the polynomial also indicates the number of roots that you will find. So in the quadratic equation it is 2, so we will generally have two solution or two roots. What is a root? First of all, I will explain this thing again in the graphing techniques, but let's understand what a root is. For any let's say quadratic equation, y is equals to ax squared plus bx plus c, a root is that value of x. I'm repeating myself. Root is that value of x's which, when substituted into that value, the equation becomes 0. Effectively, what does this thing? The entire equation becomes 0. When the equation becomes 0, you will realize that y will become 0. Now, what is y? Y is typically, I will explain it again in the graphing technique, but y is effectively the y axis and x axis. Okay, I will explain this again. But y equals to 0 is always going to lie in the x axis. This is y equals to 0, origin point. And x equals to 0, x equal to 0 ka line will always be on the y axis. This is basically what you need to realize. So whenever you have x ka some value, that will make the equation 0. And we know that there are going to be two roots. So typically the type of a graph that we will get is something like this, which will cut the x-axis in exactly 2 points. Now we will discuss about how we get to those 2 points. Let's discuss about that. Okay, we'll get back to the graphing techniques in a while, but as of now, not important. So by the very virtue of this discriminant being greater than or equal to 0, it basically takes me into 3 territories. Again, the same thing that we did for the lines, right? If it is a parallel line, a coinciding line, and so on and so forth, right? So for b square equals to ac always has to be greater than 0. Okay, you will have 3 possibilities. The first possibility is when delta is equals to 0. This is one of the possibilities. The other possibility is when delta is greater than 0. And the third and the last possibility is when delta is less than 0. So this is the first one, second one, and third one. Okay, discriminant. Obviously, we will not have to mug up anything. ये सब logically आ जाएगा दिमाग में, मतलब समझ में आ जाएगा. And when we will be using this, it will not take us more than a 20, 30, 40 seconds to recall. So again, what I'm saying the discriminant has to be equal, greater than. So let's take the first case, greater than 0, and then equals to 0, and then less than 0. So obviously it will become much more easier if I take a proper equation. Let's take, I'm forming an equation. I don't know if I will be able to form a better equation, but x is greater than x minus 2, x minus 3. This is the equation that I'm taking, the simple equation. Obviously, we don't need to expand it like the way we did. We just need to look at the roots, which are minus 2 and 3. This is going to be minus 2 and minus 3, that is minus 5. So this is going to be x square minus 5x, and minus 2 into minus 3, that is plus 6. So एक line में we can write it like this: x square minus 5x plus 6. Now this is the quadratic equation. What is the discriminant? The discriminant delta or d, whatever, is going to be b square. Now b, when you write, you will write the complete b with the sign itself. So obviously b square is 5 minus 5 ka square, that is 25, minus 4ac, minus 4 times a is 1 and c is 24. So 4 into this thing. So this is 1, which is of course greater than 1. So in this case, we are getting d is greater than 1. And obviously you can see we have, when d is greater than 1, we have two distinct real roots. This is also important, that एक तो they are going to be distinct, like दोनों अलग अलग होंगे, और real roots available होगा. So this is one of the conditions. The condition is when d is greater than 0. ठीक है. The other condition, let's take the condition when they are same. So let's take the same roots, x minus 2, x minus 2. Obviously अभी एक सेकंड में अपन इसको लिख देंगे x square minus 4x, because minus 2 is minus 4, minus 4x plus 4, because minus 2 into minus 2. Okay, now let's quickly do the write the discriminant. That is going to be 4 square. 4 square is 16 minus 4ac. 4 into 4, 16. So this becomes a 0. So d is of course equals to 0. When d is equals to 0, what is the unique thing about it? You can see it from this part also. There is only one real, or you can also say two equal roots. Okay, two equal roots you can write, or one real root, or yeah, we can write it like two equal roots. If I'm allowed to do a little bit of digression just to explain this part, I'll explain it again while graphing. This is the equation is going to be, or rather the graph is going to be something like this, just touching the x-axis. Okay, touching the x-axis. So when it is touching the x-axis, basically what is happening, it's not cutting the x-axis. So no 2 points, just 1 point. Or like if you want to sound a little smart, you can say there are the two roots are there only at 2 and 2. Both the two roots are coinciding at the same place. But again, that's not important for CAT-GMAT type of exams. The last one, that is the most important one. Not important in the sense that we just need to understand the idea. This is never going to get tested in our exams, which is a condition when discriminant is less than 0. So I have a standard equation in my mind, which is x square minus x plus 1. Now if you see this equation, if I find the discriminant now, d will be obviously 1 ka square minus 4 into 1, that is 4 only. So 1 ka square minus 4 is a negative 3. So what does this d less than 0, the discriminant less than 0 means? You will see, Soumya, you will see this thing I cannot factorize also. So I will not be able to write this thing as a x minus alpha, x minus beta. You can try that out. You will get some peculiar quantity like a root over minus 3 or something like that. Okay, so for this type of equations, we have a quadratic formula. Okay, that we will be using. I'll explain the quadratic formula in a while, don't worry. But this type of expression or equation cannot be factorized. Why? Because you cannot find two real numbers. Let me put the lingo correctly. You cannot find two real numbers, the sum of which is going to be minus 1 and the product of which is going to be plus 1. ठीक है, तो ये थोड़ा सा possible नहीं है. So whenever discriminant is less than 0, what is it that we need to understand? There are two imaginary, or if I'm allowed to use fancy words, complex. Two imaginary or complex roots. I can go into a little bit depth into it, complex conjugate, but no, not required for our purpose. So these are the three elements that one needs to understand, और ये important है, ये tests में generally पूछा जा सकता है, like what is the case when you are getting for a quadratic equation?
I have a question.
Yeah.
What does this mean? One real root, two equal roots. What does one real root mean?
So basically, the root is in the real numbers ka territory.
It's mm,
That's the only thing. Like we know that natural number, integers are all real number, na? So that's real number. That's all. Real root का मतलब ये
okay.
है.
That's okay. Okay, ठीक है, I get it.
अच्छा, अगर थोड़ा सा if I'm allowed to digress, मतलब obviously graphing तो अपन करेंगे इसका, लेकिन अगर वो if I'm obviously this is a quadratic equation, ठीक है, तो इसका ग्राफ कैसा बनेगा? There are some students who would say कि sir graph is going to be like this. This is not the graph of a discriminant less than 0. So I mean, like, okay, it's okay if you persist the graph. You can say like it's not cutting the x-axis, so maybe I can say that no real roots. But this is actually not the case. The point that I'm trying to make is that, okay, please forgive me if I again start talking mumbo jumbo, but this is the x-axis, this is the y-axis, and there is an imaginary axis also. Let's call it z dash axis. Okay, z axis is also real, by the way. Like I'm really sorry, z axis is also real. In the 3 dimension we have na length, breadth and height. So height axis also is real, but I am seeing the z dash axis as the imaginary axis. So what I am trying to tell you, ये थोड़ा सा मैं यहाँ पे मम्बो जम्बो कर रहा हूँ. So the quadratic equation is going to cut in the imaginary axis rather in the imaginary domain. If matlab obviously we are doing a live session, so I matlab online session, I cannot show you. Otherwise, if I were in a actual class, I would have basically shown you that, let's say the x z axis is over there. Okay, this is not even the image. So again, take it. I think you have understood what I'm trying to tell you. It will cut the axis, some axis, but the imaginary axis, not the real axis. Okay, this is what basically mathematicians like to ponder upon. So if you want to, like, say, ponder upon it, that's on you. I am not going to digress because that will unnecessarily waste our time. Yeah. So this is the idea of the nature of roots with the help of a discriminant of a quadratic equation. So the only thing that I need to remember is this pink highlighted area, which is discriminant will always have to be greater than equals to 0. Discriminant is b square minus 4ac. Okay, now let's okay, the last idea in this session is going to be the graphing. Oh no, before graphing also, actually after graphing I'll explain that maximum minimum to graph mein aa jayega. So now we are looking at the graphing of quadratic equation. So the only thing that I need to realize while I am forming a quadratic equation is that let's design a quadratic equation. So the equation could be something like this: x minus 2, x minus 5. And obviously this is not a quadratic, this is a factors of the quadratic equation. This basically makes my life so much more easier in forming a quadratic equation. Okay, so the quadratic equation is x square, obviously minus 7x and plus 10. This thing can be called as y. You can start off by saying that this is a function f of x, but at the end of the day, it is x square minus 7x plus 10 is equals to y. Could be, we can represent the function f of x as y. Okay, now we are going to plot it. So how do we plot it? So, okay, let me use a different, for the coordinate axis. Okay, I'm sorry if I like agar thoda sa. Okay, so just by the very factors itself, Soumya, you can see there are going to be two critical points into the graph. We have explained the idea, like why the two critical points. You can substitute a 2 into this expression and y will become 0. Okay, so these two expressions we will have to understand. Okay, now let us understand. Obviously, it is going to be a parabola. in this region, and I know how to draw the parabola, but that is not what is exciting me. What is exciting me is that this is very 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 important, because when we start discussing modulus ना, अभी inequality आएगा, inequality पे अपन modulus भी करेंगे, तो modulus में ये वाला चीज बहुत important है, तो please pay attention. So just by the virtue of these two critical points, and I will always call these the critical points, okay, okay, so these two critical points, just by the virtue of these two critical points, I have divided the entire xy plane. Let's call it the xy plane. I have divided the entire xy plane into three regions. The first region is the x greater than 5. Obviously, I mean, let's write it over there. So 2 comma 5 is the 2 points. 2 comma 5. So one of the region is x greater than 5. So any point in this region is x greater than 5. The other region is between 2 and 5. So how do we write that? We write it like this. X lies between 2 to 5. So this is how we write it, and this is how we speak it. X lies between 2 and 5. This is how we read it. And obviously the third region is x less than 2. And when I say x less than 2, this means all the way till infinity, and x greater than 5 all the way till infinity. Okay. In these three regions, Soumya, you will see a very peculiar thing happening. Okay. And obviously you should pay attention that A over there is +1, which is obviously a upward shape parabola. If I say, and Soumya, this, please pay attention to this part, because this is where it becomes important. Let me take a color. Let's take the white one only. So this, please pay attention to this thing. This is the most important part. And if you understand this part, then graphing will become like a piece of cake for all I care. All the points toward the RHS of 5 is positive. Like I'm saying, for these 2 points, just these 2 critical points, forget about everything in the world. These 2 critical points, you can take any point also, take a 6 or a 7 or whatever. You substitute the value of 6 or 7 into the equation, x minus 2, x minus this thing, you will get that this is obviously going to be 6 minus 5 is a positive, but 6, let's say minus 2, this time around, this is also a positive. So what does that mean, Soumya? That if I take any point beyond 5, everything is positive. That means the curve is always going to be positive. It is always going to be in the upward x axis domain. ठीक है, ये वाला थोड़ा समझ लेना. अगर डाउट होगा तो अभी पूछ लेना, क्योंकि ये मॉड्यूलस में बहुत यूज होगा, बिकॉज वी विल बी ड्रॉइंग द ग्राफ्स ऑफ मॉड्यूलस ऑल्सो. ठीक है, तो अगर यहाँ कहीं पे डाउट होगा तो प्लीज मेरे से पूछ लेना, वरना मॉड्यूलस वाला क्लास में भी दिक्कत होगा कि क्रिटिकल पॉइंट के नियर विसिनिटी में प्लस माइनस कैसे आप, मतलब कैसे कर रहे हो, व्हाट इज द लॉजिक बिहाइंड इट. ठीक है, अब ध्यान से देखना. और अगर इसको समझने में कहीं भी थोड़ा सा भी दिक्कत हो रहा है, बस एक चीज आप रियलाइज करो. आप सिर्फ ये रियलाइज करो कि अगर ये सेंटर होता, 0 0 ओरिजिन होता, तो ओरिजिन के इस साइड में पॉजिटिव वैल्यूज होते, मतलब आरएचएस में पॉजिटिव वैल्यूज होते, और एलएचएस में आपके नेगेटिव वैल्यूज होते. ठीक है, just by being the critical points, Soumya, understand this thing, just by being the critical points, they are basically acting as virtual origins. तो 5 के इधर सब पॉजिटिव होगा, 5 के लेफ्ट हैंड साइड में सब नेगेटिव होगा. सिमिलरली 2 के इस साइड में सब पॉजिटिव होगा, इस साइड में सब नेगेटिव होगा. ठीक है, अगर ये चीज कहीं भी, या श्योर श्योर, प्लीज प्लीज.
How is this possible that 5 के इस साइड पे
राइट हैंड साइड और लेफ्ट हैंड बोल देना.
राइट हैंड साइड पे, आई एम नॉट रियली श्योर, राइट एंड लेफ्ट. देखो,
ये this one is RHS, this one is LHS.
Okay, so yeah, so 5 के LHS में सब नेगेटिव होगा.
मतलब मैं ये नहीं कह रहा हूँ कि सब नेगेटिव, मैं ये कह रहा हूँ रीजन इज गोइंग टू बी नेगेटिव.
But then 2, I mean 2 is positive, right? Like 2 represents the positive area, right?
So whenever we are looking right now, the critical points mein we are just ignoring 2s. There will be multiple more also. If it is a cubic or a biquadratic, or bhi critical points hoga. But as of now, I'm just looking at, let's say 3, 4 till 5, 3, 4 till 5. And what I'm trying to tell you, basically what I'm trying to tell you is that if I take a point, let's say 4, is 4 more than 5 or less than 5? That is what I'm trying to tell you. 4 is definitely less than 5 na. So that is how I'm defining कि इस रीजन में, LHS वाले रीजन में सारे वैल्यूज लेस देन 5 होंगे या नेगेटिव रीजन में होगा. एंड दैट इज हाउ आई एम सेइंग कि एक एक रीजन पॉजिटिव है, दूसरा रीजन नेगेटिव है. नेगेटिव इन द सेंस कि लेस देन 0. दैट इज व्हाट आई मीन.
Like negative of the value, right?
Yeah, negative of the value. You can also say in the negative region also.
No, but that's what I'm asking. Like, are you saying negative region or your value in negative होगी or something?
नहीं नहीं, वैल्यूज नेगेटिव नहीं होगा बिकॉज ऑब्वियसली दिस इज टुवर्ड्स द. या अच्छा, अगर मेरे को रीजन पता है कि अब मैं इस रीजन पे आ गया हूं, एक एक रीजन हमारा हो चुका है, लेट्स कॉल देम ए बी एंड सी. तो सी रीजन हमारा हो चुका है, अब बी रीजन पे आते हैं. बी रीजन में फॉर 5 वी विल फाइंड the region to be negative by the same virtue. Left hand side of the origin is negative, so this is negative. But for the critical point 2, of course this is towards the RHS, so this is positive. And if I multiply them, so positive into negative is going to be negative only na. So that means ye jo curve hai, this curve is going to be like this. This curve is going to be like this. Okay, I hope you understand what I'm saying. Huh? Between 2 to 5, the curve is in the lower half of the x-axis. Lower half of the x-axis is the negative x-axis का territory. ठीक है. अब हम लोग थोड़ा सा एकदम फटाक से हम लोग समझ.
Lower half?
या प्लीज कैन यू रिपीट.
Why will it be in the lower half? वो तो negative होता है.
Yeah, and that is why we are writing it na, positive into negative. So -2 into -3 or -5 is -10. Okay. ये नहीं समझ में आ रहा है क्या?
हाँ, बस ये वाला पार्ट के नेगेटिव में क्यों जाएगा?
Basically, let me write the critical points over there, 2 and 5. So beyond 2 it is positive. यहाँ तक तो अपन समझ गए कि because of the origin factor, because 5 is acting as a origin, everything toward the RHS of the 5 is a positive region. But toward the left hand side of 5 we will find negative values, or let's say less than 5 values. So whatever number I will take, let's say if I take 4 minus 5 कितना होता है सौम्या? -1 होता है ना सौम्या? -1 होता है ना. तो -1 विल बी इन द इफ आई. और ये -1 सौम्या एक चीज मेरे को बताना, अगर हम इसको एक सेकंड के लिए भूल जाए, -1 ये क्या है? y इज इक्वल्स टू -1 है ना, और y इज इक्वल्स टू 0 तो यहाँ है ना. -1 तो यहाँ पे होगा ना, फिर -2 यहाँ पे होगा. इसीलिए हम इसको ऐसे इस तरह से करते हैं. नेगेटिव रेंज में अब वो जा रहा है. एक सेकंड के लिए x -2 को भूल जाओ. अगर एक ही लाइन होता तो ये इस तरह से जाता. ठीक है, अगर एक ही कोऑर्डिनेट होता तो सिर्फ इस तरह से होता, लाइन कुछ इस तरह से होता कि नेगेटिव टू पॉजिटिव, और यहां पे 5 पे उसका चेंज होने वाला है, साइन चेंज होगा. दैट इज व्हाई वी से 5 and 2 एज द क्रिटिकल पॉइंट्स, बिकॉज 5s में 2s में चेंजेस आता है उसका साइंस का. ठीक है, इसको रटवाते भी हैं कुछ लोग, मैं बताऊंगा आगे कैसे रटवाते हैं. ठीक है, अगर वो काम आएगा तो उसको रट लेना, बट अभी इसको ऐसे समझ लो. ठीक है, ओके लेट्स. अब लास्ट टेरिटरी का अभी तक तो हमने समझ लिया कि बिटवीन 2 to 5 इट इज गोइंग टू बी इन द नेगेटिव जोन. बियॉन्ड 2 ऑब्वियसली, बियॉन्ड 2 द एलएचएस इज नेगेटिव. Okay, beyond 5 is it's negative, so negative into negative, that means it has to be positive, so this range is again going to be in the positive range. And now you know why the graph is like this, a U-shaped graph. ठीक है, एक बार इसको देख लो, एक बार इंटरनलाइज कर लीजिए, उसके बाद अगर सवाल है तो पूछिए, वरना वी विल गो टू द नेक्स्ट आइडिया. दिस इज इंपॉर्टेंट बाय द वे. Let me also write one more thing. This region is positive, this region is negative, this region is positive. और यही हम करते थे जब भी हमको याद है ना, जब हम पॉइंट करते थे, अगर मैं -2 को और 5 को पॉइंट करूं तो हम पॉजिटिव नेगेटिव पॉजिटिव लिखते थे. सो दिस इज दैट पॉजिटिव रेंज, द नेगेटिव रेंज एंड द पॉजिटिव रेंज. सो द ग्राफ इज ऑलवेज गोइंग टू बी लाइक दिस. ठीक है, और एक हमको कभी, अगर आप, मुझे नहीं पता अगर आपने किसी YouTube में या कहीं भी आपने किसी भी फैकल्टी को देखा होगा, एक जनरली ऐसा कहा जाता है कि जब भी आप प्लॉट कर लो अपने क्रिटिकल पॉइंट्स को, 2 को और 5 को, तो व्हाट यू बेसिकली डू इज आफ्टर यू प्लॉट द क्रिटिकल पॉइंट्स, इट इज ऑलवेज अंडरस्टूड कि जो राइट हैंड मोस्ट पार्ट होगा वो पॉजिटिव होगा, और उसके बाद नेगेटिव पॉजिटिव होता जाएगा इफ इट इज अ a polynomial function. Or this method is called as the wavy curve method. This is something which is not even taught in the school days. It is a method that is taught in the IIT JEE preparation, but it's not required. मैंने आपको लॉजिक बता दिया कि वो पॉजिटिव क्यों होता है. अब आपको रटने की जरूरत नहीं कि हमेशा राइट हैंड साइड में पॉजिटिव से स्टार्ट होगा, फिर ऑल्टरनेट नेगेटिव पॉजिटिव. ठीक है, वो सब अब रटने के खत्म हो गया है सिचुएशन. अब हमको लॉजिक समझ में आ चुका है. I'm just going to be quiet for some time just so that you can internalize it and we can move further.
Yeah, I get it.
It's okay, na?
Hmm.
Ek second, just give me 1 minute. Let me sip some water. We'll do some questions also today, don't worry. Like it's all theory. Last day also we did, I mean, last class also we did a lot of theory, but today we'll do a little bit of questions also. Just give me 1 minute. Let me just sip some water. Okay. So this is the y is equals to 0 line, or x-axis, you can say x-axis. And couple of things, noteworthy points that we should be keeping in mind. By the very virtue of this equation, 1x square minus 7x plus 10, we know just by looking at it, it will be an upward facing. You can call it an upward facing graph also, but just like if I am, again, if I'm allowed to use fancy words, upward facing parabola. Parabola is the name of the conic. Again, a jargonish term. Also, one interesting thing, Soumya, I'm very loud. I mean, I'm very bad at my drawing, but this is a symmetrical parabola. So this U shape is not going to be like जैसे मैंने यहाँ पे अगड़म मगड़म कर दिया, ऐसे नहीं होगा. ये एकदम symmetrical U shape होगा. And if it is symmetrical, then there will be an axis of symmetry or a line of symmetry, and the line of symmetry will run exactly in the middle. So इसको अगर मैं यहाँ पे थोड़ा सा explain कर दूं, so line of symmetry एकदम middle से होकर के पार होगा. What does the line of symmetry means? कि left hand side का जो भी curve है, that is going to resemble exactly to the RHS of the curve. ठीक है? This is what I mean by the symmetry. So whenever we have a quadratic equation, it will always be symmetrical. ठीक है? Please ignore if the spelling and all is not right. ठीक है? अब जो हमने अभी थोड़ी देर पहले डिस्क्रिमिनेंट वाला डिस्कस किया था, नेचर ऑफ द ग्राफ. ठीक है, नेचर ऑफ द ग्राफ पे अगर मेरे को फिर से कमेंट करना है, तो व्हाट आर द थिंग्स दैट आई वांट टू टॉक अबाउट. नेचर ऑफ ग्राफ इज ऑलवेज गोइंग टू बी डिपेंडेंट ऑन द साइन ऑफ a meaning the coefficient of x square. That means it's a upward facing parabola. So the parabola is going to be a u, upward facing u. And it will also be dependent, the nature of the graph will also be dependent on the sign of the discriminant d. Whatever the sign that I get, sign का मतलब है, is it greater than 0? If it is greater than 0, then obviously it cuts the x-axis at two distinct points. Obviously, you can see it over there that it is cutting the x-axis at two distinct points. That means that yes, the discriminant is greater than 0. Okay. Had it been equals to 0, then it would have touched the x-axis at exactly 1 point. Obviously, if it's touching it, then touching it at exactly 1 point only. There's no touching ka matlab hai that's only 1 point. So it just touches the x-axis. And if it is less than this thing, then it never touches the x-axis. Ideally, I've told you the idea of where it intersects in the imaginary plane, but again, that's beyond the scope of our discussion. So now we need to understand a very critical element through this graph itself. Now, please understand, Soumya, the type of questions that generally are tested in aptitude exams, be it a CAT or a GMAT or whatever, you will see generally they will be talking about a maxima or a minima of a quadratic equation. Okay. So maxima and minima. Uh, so एक बार खाली just look at this graph and tell me, will you get a maxima of this graph or a minima of this graph?
Maxima.
No. See, maxima का मतलब होता है the maximum value. Obviously, it is an upward facing parabola. That means maximum to infinity है, तो खुलता जाएगा, खुलता जाएगा, खुलता जाएगा, तो infinity तक चला जाएगा.
Okay.
Yeah.
Next.
So with that logic, you will find a minima or a minimum value of this quadratic equation. अच्छा, एक और interesting सा चीज notice करना. ये ग्राफ थोड़ा सा गंदा हो गया है, तो मैं इसको थोड़ा साफ करता हूँ. यहाँ पे ना कुछ बियॉन्ड दिस वी आर नॉट गोइंग टू मग अप एनीथिंग. कोई फॉर्मूला वॉर्मूला मुझे नहीं रटना है. आई जस्ट वांट टू विजुअलाइज एवरीथिंग. सो अगर मुझे पूछा गया है क्वेश्चन में व्हाट इज द मिनिमा ऑफ दिस whatever this equation, this quadratic equation, so the minimum of this quadratic equation is lying exactly at this position na, and you will realize that the minima is exactly in the center of the two roots, which is 2 and 5. So can I not say that it is going to be the average of these two roots? मतलब एकदम center में है ना, 2 और 5 के बीच में. So it could be like a 2 plus 5 by 2. ठीक है. But that is one thing. That is one thing. The other thing is that what is 2 and 5? If I'm just allowed to write it like this, can I write it like 2 plus 5 by 2? ठीक है. इतना तो हमने अभी डिस्कस किया कि ऐसा क्यों हो रहा है, एकदम एग्जैक्टली इन द मिडल है, और वो भी लाइन ऑफ सिमेट्री के एकदम एंड पॉइंट में है. What is 2 plus 5? These are the sum of roots ना. सम ऑफ रूट्स बाई 2. सम ऑफ रूट्स का वैल्यू क्या होता है? माइनस बी बाई ए होता है. ठीक है, माइनस बी बाई ए. बट रिमेंबर देयर इज अ 2 ओवर देयर. सो माइनस बी बाई 2 ए, दिस इज गोइंग टू बी द पॉइंट ऑफ मिनिमा. ये सब रटवाया जाता है बुक्स में कि व्हाट इज द पॉइंट ऑफ मिनिमा. बस रट लो माइनस बी बाई 2 ए. ये मैंने आपको विजुअली बता दिया कि माइनस बी बाई 2 ए क्यों होता है. ठीक है, दिस इज द पोजिशन. माइनस बी बाई 2 ए क्यों हो रहा है? बिकॉज सम ऑफ द रूट्स इज माइनस बी बाई ए, and obviously denominator में you have a 2, so that is where the 2 is coming into the picture. And if it were a, let's say, downward facing parabola, let's take some space. Had this been something like this, I'm very bad with the, being a faculty I shouldn't be bad at drawing, but I'm very bad at, actually I'm using a pen tab pen tool kind of a situation ना, इसीलिए ऐसा होता है. Otherwise if I'm doing it freehand, then not going to be that much of a problem. Again, you can see the two roots, alpha and beta, and exactly in the middle you will find the maxima. Okay, and do I really need to again comment? It is going to be the same, sum of the roots by 2 minus b by 2a. ठीक है, that is going to be the point of minima. एक बार बता दो, like is it okay or not?
Yeah.
All right, let me now get to a fresh position. So just by looking at the graph itself, we can have multiple possibilities. Okay, with the discriminant. So what basically I was telling you is that I don't know if I will be able to explain this part in a good way. Let's see. So just for the point of maxima and maxima minima, I'm trying to explain this thing. The different types of the graphs that we can form when we have a certain value of a and the discriminant d. Okay. So without further complicating it, मेरे को किस किस तरह के graphs मिल सकते हैं? Just to give you an overview. The first case. A is greater than 0, D is greater than 0. So what is the graph that you can typically find? You can find a graph like this, intersecting in two distinct points. This is the graph of a situation like this. Another point that we just now discussed is that A could be greater than 0, in which case, again, it's an upward parabola, but D is equals to 0. In which case, the graph is going to be something like this. Just now we discussed, going to touch exactly at one point. And the third case is when A is greater than 0, but D is less than 0. In which case, ये जो ग्राफ है ये तो टच ही नहीं करेगा x axis को, ठीक है? But one thing that you need to understand is that the graph is upward facing. It's positive in the upward region. But what if it is the all एकदम मतलब उसका अब water images हम ले रहे हैं, sorry, the mirror images, ठीक है? So A is less than 0, D is greater than 0. So D remains the same. D के तीन ही property हैं, greater than 0, equal to 0, less than 0. So D के property same है. Now, if it is going to be A less than 0, obviously you know it. I don't have to explain it again. It is exactly going to be the mirror image. ठीक है? This is the fourth one. Sorry. The fifth one is going to be when, let's say, A is less than 0 and D is equals to 0. In this case, again, you know, it is going to be a parabola. Sorry, it is going to be a parabola, but the parabola is just going to touch it. ठीक है? गलती से cut हो रहा है, but you get it. Okay, you get it. Sixth one, the last one, which is A also less than 0, D also less than 0. And obviously, we don't really need to worry too much, not touching the x-axis at all. In the negative zone, this one is in the positive zone. That's all that I have to understand. And this is just coming out from the fact of the discriminants and the coefficient of x square. एक बार खाली मतलब, if this is okay, just give me a prompt, we'll go further. These are the 6 different type of graphs that one can have for quadratic equation. That's it. This is other graphs.
A again.
Which one?
A.
A is okay for the expression ax squared plus bx plus 3. This is the A. Okay.
Okay, got it.
Let's go to the next one, shall we?
Yeah.
It's 12:30. जैसा मतलब अगर लगे कि ज्यादा हो रहा है तो प्लीज डू टेल मी. लाइक है नहीं इसमें ज्यादा कुछ, बहुत ही बेसिक सा चीज है ये. फालतू में इसको थोड़ा सा ये डरावना बनाया जाता है, बट ये है नहीं वैसा कुछ भी इसमें. We have discussed about the maxima and the minima also. If I am just allowed to थोड़ा सा बस एक बार recap करने के लिए, okay, just if I have ये बार should, yeah, this is better. This is far better. In this case, what I am getting is A is greater than 0, and obviously in this case you will see the minima occurs. Let's take 3 and 7, the 2 points. So 3 and 7 is 10, 3 sevens are 21. So this is going to be minus 10x plus 21. Okay. This is equals to whatever 0. For the time being, just forget about whatever is getting equated to. Just, there are 2 things that we need to pay attention to. The first thing is that A is greater than 0, and obviously because of the nature of the graph, the discriminant is greater than 0. Now we know that this point is going to be the point of minima. Okay, the point of minima. So anytime सौम्या चलो मान लिया क्वेश्चन पूछ दिया कि फाइंड द पॉइंट ऑफ मिनिमा ऑफ दिस इक्वेशन, ऑफ दिस क्वाड्रेटिक इक्वेशन. मेरे को फॉर्मूला नहीं याद है, Forget about the formula. You know the idea. The idea is it is always going to be exactly in the middle of the two roots. ठीक है, line of symmetry पे ही होगा और exactly in the middle of the two roots. That is going to be what? 3 plus 7 by 2. That is going to be nothing but 10 by 2, that is 5. So this is my point of minima. Sum of roots by 2. अगर if I'm just digress, if I'm not digressing, then this is equals to minus b by 2a. अच्छा, एक इंपॉर्टेंट चीज है वैसे यहाँ पे बताना, मुझे लगता है बता देना चाहिए, ठीक है? आई डोंट नो, ये आप, आई शुड नॉट से लाइक, बट लेट्स से there is a difference between, Soumya, please understand, there's a difference between point of minima and the minimum value. एक बार खाली मेरे को आप एक बार आप मेरे को बता दो कि आप क्या समझते हो दोनों से, एंड देन आई विल स्टार्ट एक्सप्लेनिंग, अदरवाइज वही होगा कि रटने वाला सीन नहीं करना है, समझना है इसको. पॉइंट ऑफ मिनिमा, पॉइंट ऑफ मिनिमा का मतलब क्या है? इट इज द coordinate point or the coordinate axis of that point. Okay, so whatever 5 comma something, if you realize, Soumya, this uh, whatever this line is, this is lying in this curve na. So curve का जो value होगा, मतलब obviously you now you will understand what I'm saying, कि इस exact point पे जहां पे मैं कह रहा हूं दैट 5 इज द पॉइंट ऑफ मिनिमा, एक y का भी पॉइंट लाई करेगा, और इसी y के पॉइंट को मिनिमम वैल्यू ऑफ द क्वाड्रेटिक इक्वेशन कहते हैं. जब वो आपसे क्वेश्चन पूछता ना, ये कंफ्यूजन बहुत क्रिएट करता है स्टूडेंट में कि सर व्हाट द नॉनसेंस, एक बार मिनिमा बताया फिर मिनिमम वैल्यू बताया, क्या डिफरेंस है मिनिमम में मिनिमम वैल्यू में? ये डिफरेंस है. मिनिमा इज द पॉइंट ऑफ दैट एक्स कोऑर्डिनेट एंड मिनिमम वैल्यू इज द पॉइंट ऑफ दैट वाई कोऑर्डिनेट. ठीक है, ये सब इसलिए नहीं थोड़ा सा डिफिकल्ट हो जाता है क्योंकि हमने शायद काफी टाइम के बाद हम क्वांट्स पढ़ या फिर अलजेब्रा कर रहे हैं, तो इसलिए एक बार ये चीज एक बार दिख गया ना, फिर जिंदगी में कभी ये दिक्कत नहीं करेगा कि मिनिमम वैल्यू और पॉइंट ऑफ मिनिमम में क्या डिफरेंस है. तो इज इट ओके ना?
Yeah.
तो सौम्या, अगर सवाल ये हो कि नाउ टेल मी व्हाट इज द पॉइंट ऑफ मिनिमम, तो हम करेंगे क्या? हम क्या करेंगे, ये जो वैल्यू आया ना सौम्या, तो एक्स कोऑर्डिनेट का वैल्यू आया, हेलो, ये एक्स कोऑर्डिनेट का वैल्यू आया ना, वटेवर, ये 3 भी एक्स कोऑर्डिनेट में है, वाई भी 7 भी एक्स कोऑर्डिनेट में है, तो ये तो एक्स कोऑर्डिनेट का वैल्यू है एक तरह से, जो मैं यहाँ पे बता रहा था कि एक्स कॉमा वाई में हमने 5 को फाइंड आउट किया है, दैट इज द पॉइंट ऑफ मिनिमा. अब आपसे अगर मैं पूछूं कि मेरे को वाई का वैल्यू बता दो क्या है, तो आप सिंपली मेरे को बोलोगे कि सर जस्ट सब्सटीट्यूट द वैल्यू ऑफ 5 इनटू द एक्सप्रेशन, यू विल गेट द वैल्यू. पुट कर दो 5, पुट कर दो उसमें, एक्स स्क्वायर माइनस 10x प्लस 21 में, एंड यू विल गेट द वैल्यू ऑफ दिस थिंग. तो अगर कोई बोले कि मिनिमम वैल्यू बताओ, what is the minimum value of this quadratic equation, now can you tell me, yes or no?
Yes.
Can you tell me quickly, कर लो एक बार calculate, it will not take you more than let's say 30 seconds.
Okay. That is 10x, right? Or 16x?
10x 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 minus 3 minus 7.
Okay. Minus 4.
Yes.
I have a question.
Yeah, please say.
How do you know? Like, I remember while you were explaining one of the previous things,
Yeah.
in Abhi, like 5 minutes, 10 minutes
Hmm.
back, you said that the equation is equal to y, so that's the value of y. So how do we know what value we're calculating?
एक मेरे को ना नहीं समझ में आया, एक बार कैन यू एक्सप्लेन इट अगेन, लाइक व्हाट इज इट दैट यू आर आस्किंग?
Like you're saying that अभी हमने 5 x का वैल्यू निकाला, right?
हाँ
5.
हाँ।
How do we know कि हमने x का ही निकाला है? Like because in one of the previous equations you said the equation equals to y.
नहीं नहीं, what I told you, it's not yeah, so what I told you is that this line is y equal to 0.
अच्छा,
तो
okay.
इस लाइन में y इक्वल टू 0, विच y इक्वल टू 0 और x एक्सिस, तो इसमें जो भी पॉइंट्स पड़ेंगे 3 और 7, ये तो x कोऑर्डिनेट्स ही हैं, ठीक है? आई होप दैट इज क्लियर नाउ।
हाँ, ये तो x कोऑर्डिनेट्स होंगे।
और इस वाले पॉइंट का हमने ऑब्वियसली, हम जब इन दोनों से हम इन दोनों का एग्जैक्टली मिडिल वैल्यू निकाल रहे हैं, तो एक्स कोऑर्डिनेट ही निकलेगा। अब एक्स कोऑर्डिनेट मेरे को मिल गया, हाउ डू आई कैलकुलेट द वाई कोऑर्डिनेट? सब्स्टिट्यूट इट इनटू द इक्वेशन, बैक इनटू द इक्वेशन, यू विल गेट द वैल्यू। सो दैट्स द ओनली आइडिया। अब इस पॉइंट के बाद कुछ भी फालतू का चीज नहीं रटना है कि अच्छा पॉइंट ऑफ मिनिमा इज माइनस बी बाई टू ए, अच्छा मिनिमा इज डिस्क्रिमिनेंट, इट विल बी माइनस डी बाई फोर ए, एंड इट इज गोइंग टू बी दिस एंड दैट एंड ऑल। जस्ट डोंट डू इट, यू हैव द आइडिया ऑफ द लॉजिक, now please try to apply this logic in your questions. Okay, I'll give you some questions also to practice, don't worry. In the meantime, like, you can use the modules also. The modules are very good in that sense. And yeah, uh,
Okay.
एक चीज है last, and then we'll wind up with the questions. Maybe we can do the questions tomorrow if you are available tomorrow.
Yeah. Okay, I think we can move on to the next thing.
Yeah. Just a second.
Yeah.
So this is the last iteration of quadratic equation. So sometimes when, you know, as in when we are talking about the maxima minima of a quadratic equation, generally what happens is that, yeah, this is perfect, we can use these things, like if I have the graph in the mind and stuff, everything is perfect. But what I'm trying to tell you is that mostly what happen, or more often than not, what happens is that you will have a quadratic equation, and generally they'll be asking you what is the minimum value or the maximum value. Obviously, if the coefficient of x square is positive, you will invariably be getting a minimum value. So there is a very, let's say, elegant way to find the minimum value or the minima of any quadratic equation. How do we do that? And that we do by the idea of completing the square. So there is something called as the method of completing the square. What do I mean by that? Obviously, if you realize this x square minus 10x plus 21 should resemble something, x plus y the whole square. Now this is a perfect square, mind you. X plus y the whole square is a square plus whatever this is, like you substitute some value, 1 plus 2 3, 3 ka square is 9, 9 is a perfect square. What do I mean by that, Soumya? परफेक्ट स्क्वायर का जो मिनिमम वैल्यू होगा ना, बिकॉज आई एम टॉकिंग मिनिमम, बिकॉज यहाँ पे कोएफिशिएंट ऑफ एक्स इज पॉजिटिव, सो हमेशा मिनिमम आएगा। तो परफेक्ट स्क्वायर का, दिस इज समथिंग दैट वी हैव डिस्कस्ड इन नंबर थ्योरी आल्सो, दैट परफेक्ट स्क्वायर का जो मिनिमम वैल्यू होगा दैट इज गोइंग टू बी 0. इट कैन नेवर बी नेगेटिव. व्हाई? बिकॉज ऑफ द सेम रीजन, राइट? एक्स माइनस वाई का अगर आपको मिनिमम वैल्यू निकालना है, एक्स माइनस वाई का स्क्वायर का मिनिमम वैल्यू निकालना है, तो ऑब्वियसली अगर आप नेगेटिव वन भी लिख दो एक्स माइनस वाई के जगह पे और इसका स्क्वायर कर दो, तो ये तो वन ही आएगा। तो द लीस्ट दैट यू कैन गेट, द लीस्ट पॉसिबल वैल्यू दैट यू कैन गेट इज 0. नाउ दिस इज गोइंग टू बी वेरी हेल्पफुल फॉर अस व्हाइल कैलकुलेटिंग सर्टन ideas. For example, just I will take this equation itself. अब मैं आपको एक्सप्लेन करने की कोशिश करूंगा मेथड ऑफ कंप्लीटिंग द स्क्वायर। ये थोड़ा सा ट्विस्टेड है, ये मैं फिर से बोल रहा हूं, ये थोड़ा सा ट्विस्टेड है, तो थोड़ा सा केयरफुली करना पड़ेगा, वरना गलती हो सकता है, ठीक है? तो व्हाट आई एम ट्राइंग टू टेल यू इज दैट of the same equation, x square minus 10x plus 21, this is what we took as our quadratic equation. इफ आई एम अलाउड सौम्या, जस्ट एक चीज याद रखना कि मिनिमम वैल्यू यहाँ पे -4 आया था, ठीक है, दिस इज व्हाट वी कैलकुलेटेड, ठीक है, लेट्स गो बैक, ठीक है, मिनिमम वैल्यू -4 आया था, दिस इज व्हाट वी नीड टू रिमेंबर. Okay, for perfect square, let's try to predict some patterns. X minus 1 the whole square can be written as x square minus 2x plus 1 a square, and this is how ideally it should be written, a square minus 2ab plus b square. Ideally मतलब ऐसे ही मैं बोल रहा हूँ, बट ऐसे ही हम लिखे और समझे तो ज्यादा बेहतर होगा. x minus 2 the whole square can be written as x square minus of 4x and plus of 2, sorry 4, x square minus 4x plus 4, ठीक है. Now typically what I'm finding out over there is that what I'm finding it out over there, ये whenever I have an equation like this x minus 2 the whole square, just pay attention, ये जो middle term है it is the twice of that, ठीक है, it is the twice of that. अब इस वाले इक्वेशन को थोड़ा सा इसके साथ कंपेयर करता है, ठीक है. अगर हम कंपेयर करेंगे इस वाले इक्वेशन को इससे, तो वी कैन राइट इट लाइक दिस, एक्स स्क्वायर माइनस 10x प्लस 21, लेट्स कीप इट एट 21 ऑल्सो, ओके, जस्ट फॉर द सेक ऑफ इट. बट अगर आप मेरी बात समझ पा रहे हो, दिस इज 4x, half of that should be written in the squared form, so I can write it like this, x minus 5 the whole square. लेकिन अभी गलत हो जाएगा, अभी गलत हो जाएगा, ठीक है, हमको थोड़ा मैनेज करना पड़ेगा. अभी 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 ये सारा सिचुएशन अभी गलत है. अगर इसको हमको मैनेज करना है तो इस कांस्टेंट टर्म को भी थोड़ा सा चेंज करना पड़ेगा. कैसे? सो वी नीड 21. हाउ कैन वी हैव अ 21? सो वी आई कैन राइट इट लाइक अ 25 माइनस 4. एक बार खाली मेरा मेरा चीज इसको यहां पे समझने की कोशिश करो. व्हाट इज इट दैट आई हैव रिटन ओवर देयर? ठीक है, एवरीथिंग इज परफेक्ट. सडनली हाउ इज इट दैट आई एम एडिंग ट्रांसफॉर्मिंग 21 टू 25? हमने कोई ट्रांसफॉर्मेशन नहीं किया है. व्हाट वी हैव डन इज वी हैव ट्राइड टू मॉडल दिस थिंग इनटू अ परफेक्ट स्क्वायर. तो परफेक्ट स्क्वायर बनाने के लिए जो भी मिडिल टर्म है उसका आधा लिख करके होल स्क्वायर लगा देंगे. लेकिन 5 स्क्वायर तो 25 देता है और मेरा कांस्टेंट इज 21. तो अगर 25 मैंने लिखा है, क्योंकि अगर मैं x माइनस 5 होल स्क्वायर को एक्सपैंड करूंगा तो दिस विल बी एक्स स्क्वायर माइनस 10x प्लस 25. लेकिन मेरा ओरिजिनल इक्वेशन 21 का है, तो एक -4 डाल दो एडजस्ट करने के लिए. यहां पे हमने वही किया है, 25 माइनस 4, ठीक है, ये एडजस्टमेंट के लिए है. अब आप ध्यान से देखना, ये वही इक्वेशन था जिससे हमने स्टार्ट किया था, एक्स स्क्वायर माइनस 10x प्लस 21. और जब हमने इसको मेथड ऑफ कंप्लीटिंग द स्क्वायर वाला फंडा यूज किया, और ये वाला चीज थोड़ा करना पड़ेगा, ठीक है, दिस विल टेक प्रैक्टिस. अगर ये वाला चीज यहाँ पे नहीं समझ में आता, ये प्रैक्टिस 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 आएगा. वरना जब मैं क्वेश्चन सॉल्व करूंगा तो मैं इंडिविजुअली बताता जाऊंगा एक के बाद एक के बाद एक, ठीक है. ध्यान से देखना, x माइनस 5 द होल स्क्वायर इज गोइंग टू बी इक्वल्स टू y. अगर मैं आपसे पूछूं कि सौम्या टेल मी व्हाट इज द मिनिमम वैल्यू ऑफ y, तो आपके दिमाग में दो चीजें चलेंगी. पहला, एक तो मिनिमम वैल्यू y का इसके वजह से आ सकता है या इसके वजह से आ सकता है. दिस इज अ परफेक्ट स्क्वायर, तो परफेक्ट स्क्वायर का मिनिमम वैल्यू इज ऑलवेज 0. सो यहां से तो मेरे को 0 ही मिलेगा. लेकिन होल्ड ऑन, देयर इज अनदर एंटिटी ऑल्सो -4. सो द मिनिमम वैल्यू ऑफ y माइट एज वेल बी -4, क्योंकि x माइनस 5 का वैल्यू हम 0 ले सकते हैं, दैट इज अलाउड. क्वेश्चन में मिनिमम वैल्यू पूछा है, दैट इज -4. अब एक बार मैं सिर्फ यहां पे दिखाना चाहता हूं, क्या ग्राफिंग मेथड से या ग्राफिकल मेथड से भी -4 आया था हमारा? यस, -4 आया था. दैट मीन्स मेथड ऑफ कंप्लीटिंग द स्क्वायर वाला फंडा भी सही है, ठीक है. एक बार जस्ट कंफर्म टू मी वंस इफ दिस इज ओके.
Yeah.
ये लास्ट वाला, दिस इज अ लिटिल, आई वुड से इंपॉर्टेंट, अ लिटिल ट्विस्टेड. यहां पे यू विल हैव टू यूज क्वेश्चंस टू अंडरस्टैंड दिस थिंग, ठीक है. इसके फॉर्मूला वर्मूला भी आता है, b/2 करके उसका स्क्वायर कर देना एंड ऑल दैट नॉनसेंस. आई थिंक ना दिस इज फार मोर एलिगेंट, लाइक वो सब याद भी नहीं रहेगा, तो माइट एज वेल लेट्स नॉट इवन डिस्कस दैट. व्हाट आई एम सेइंग इज, जब भी कभी भी प्रॉब्लम आ जाए ये चीज समझने में कि कैसे मेथड ऑफ स्क्वायर करते हैं, दो नंबर ले लो, x-1 का स्क्वायर, x-2 का स्क्वायर, उसको एक्सपैंड करो और ऑब्जर्व करना कि जो इक्वेशन है ए एक्स स्क्वायर प्लस बी एक्स प्लस सी के फॉर्म में, उसका जो मिडिल टर्म है उसका हाफ आ रहा है एक्स माइनस वाई द होल स्क्वायर के होल स्क्वायर में, एंड ऑल दैट यू नीड टू, उसके बाद यू नीड टू मेक एडजस्टमेंट्स, दैट्स इट. थोड़ा सा प्रैक्टिस के बाद यू कैन लाइक डू दीज थिंग्स इन अ जिफी. And with this, basically, the first part of quadratic equation ka theory is over. Let's do one thing now. Let's just call it a day. We started off also a little late. So these are all the theories. I will give you the questions in your chats. I will give you the questions also if you want to just keep a tab of your practicing. From tomorrow, we will do the, in any case, we have a class tomorrow, it's Monday. So from tomorrow, we'll basically start solving the questions. Acha, questions maybe we have two parts. One is the polynomial theory, and आज जो हमने किया quadratic equations का. So there are round about 10, 15, 20-ish questions. We'll do these questions tomorrow. I don't think that should be a problem. Yeah.
Okay.
ठीक है then. I'll send you the recording. Good night.
Okay. Thank you.
Yeah. Yeah.